All right, well, what we like to do over here is we just want to first do a shout out from all the cities, because tonight we have 4 cities. We have Milwaukee, Chicago, Pittsburgh, and Denver. So, yes, so everyone get ready for Milwaukee. All right, Milwaukee, let's say hello to everyone else. We will go to Denver. Denver, can we hear some of your love out there? All right, Denver, I've been to Denver and I feel like you guys can do better. I'm just gonna say that. All right, Denver, let's all right, Denver, let's hear you guys one more time. Okay, that's more like it. I'm like, Denver people are really cool. And then Pittsburgh. All right, love it. And if you have any questions, either during the event about, from a speaker, maybe just like what's going on in Denver, or what's going on in Milwaukee or Pittsburgh or Chicago, just go ahead and tweet tonight or during the presentation. We'll definitely follow up with you guys afterwards. What? The hashtag is ReactJS United. And that's where you are, FYI. That's what this event is. You're not supposed to be here. It's okay. All right, Chicago, how are we doing?
All right, do it again.
Okay. Woo! Okay. All right, yes. All right, Chicago. Do you guys want to do that one more time, Chicago? Like, I feel like maybe, no?
I feel like Chicago should be loud.
I know. Chi-Town. Okay. All right, everyone is good. Phew, it's only 6:39, so we're okay. First of all, I just want to say thank you to everyone, all of the organizers who have been working with me on this for probably about 5 months now to get tonight just working and running, and with all the technical issues. All the sponsors from all the different cities, but specifically here in Milwaukee, we want to thank NM for just believing in having free technical community space and like a spot for everyone to learn and connect. We also are going to have a link at the end or throughout, maybe when we're doing some of the switchovers from some of the speakers, on a survey. So it'll be super short and sweet. It's a bit.ly link. I'll give it to you guys just to let us know if you like this sort of thing. Do you want to see more of it? And then the other thing is, I just want us all to have a really awesome time and connect with people on LinkedIn that you see tonight in Chicago, Milwaukee, Denver, Pittsburgh. I've worked with all of these organizations. Still might be my favorite. They're all super cool.
That's just because you're here.
I know. But and we have really good beer and like really good burgers and all that sort of stuff. But so you can come visit us. But all of the groups have been just tons of fun and just like a plethora of knowledge everyone's blown us away with. And just cool people. So without further ado, just to let you know the agenda tonight. We're going to do Milwaukee, then we'll have Chicago, and then we have 2 speakers from Denver. So with that, I'm going to turn it over to Josh Compton. Woo!
Okay, and we're gonna tempt fate a little bit because we do have to switch to another PowerPoint. So let's see what happens. We're gonna tempt fate. Okay, so we're going to do this. Pause. How we looking? No? Wrong one? Okay. We're gonna do, oh, actually I gotta start the presentation first. That's what it was. All right. So we did this.
Oh, there it is.
Look at that. Yes? No? All right. So now, because Microsoft is amazing, we have to do this, and then we have to do this.
Ah, the old switcheroo.
Yeah, turn it on, and back off, and back on again. All right. Well, thank you, everyone, for coming to this fantastic React United meetup. Hashtag React JS United. No spaces. That's not how hashtag works. Okay, so I'm Josh Compton, Josh T. Comp on all the platforms where you should find me, including Twitter. So if you want to tag me, I will. I am the tech lead for the field experience design system of the of Northwestern Mutual. That's a big way of saying that I do NPM tools, essentially. And I'm also the engineering advocate for the New York office. So they were kind enough to fly me in all the way from New York. Probably could have gone to Pittsburgh, but you know, Milwaukee's pretty cool. So, okay, let's get going. Why does it not want to switch? Okay, so I'm an engineering advocate, so I have to tell you what I do. So we do engineering culture. We have a bi-weekly lunch and learn. I'm not going to get too much into that. We do tech outreach like this, and I also build a lot of engineering tools like the UI Toolkit, which is an NPM tool. So tonight we're going to do a bunch of stuff, and so you see that we have a pretty objective timetable for what we're going to be trying to cram into like 15 minutes. So I'm going to ask everyone to hold their questions until the end. I'm going to try to give enough time for that. But we're going to review what semantic versioning is, or SEMVer. We're going to learn about NPM. We're going to learn the whole thing. We're going to automate version bumps and publishing. We're going to generate changelogs. We're going to deprecate properly without ruining everyone's apps in prod. And then we're going to enforce some rules. So quick note. Any examples that you see in here are for JavaScript and NPM because that's what I use, so I'm selfish. But these concepts can be used for any project. So I'm going to take a breath. Are we ready? Cool. All right, so semantic versioning. So I want to stress that all these rules are for the public APIs, not for your internals. So anything that you have namespace by __ dangerously set whatever, it's not for this. So a version number should follow the pattern of 0.y.z is for beta. Probably shouldn't do that. If you're doing things right, you should just hold yourself accountable from day one. After 1.y.z, everything should be reverse compatible. So again, unless you're like are really unsure of the future of your tool, try not to use 0. And no takebacks, only updates. You deprecate busted things. You don't just like take it back. You don't say that, okay, so 1.2 is now this, even though we've released 1.20 earlier. Again, only throw. So, okay, so SEMVer is a social contract for communicating the nature of the changes that you published. It's a social contract. That's really important. So again, we have a review of what all of these are. So this is what the spec of SEMVer is saying to everyone. So they have major updates, which is the 1, minor, which is 2, patch, which is 3. So you might be asking yourself when you're thinking about which version bump you're trying to make. A lot of work went into this release. Is it a major release or a minor? And I will say to you that that is sentimental versioning. And there's a link. I believe we are going to be sharing these slides afterwards. If not, Google sentimental versioning and read it because it's great. But that is to say, we're not talking about the amount of effort that we put into the tools that we're publishing. We're talking about the changes that we actually made. So a better way of thinking about this is this far left number is breaking changes. This means that you're going to have to do something to continue to use this tool. The middle number is a feature. So anything new that you're adding that's like new functionality. And then that far right number is a fix. If you only throw. Another way of thinking about this is semantic versioning is your BFF. Okay, so sentimental versioning, big new feature. It's 2.0. No, stop. Bunch of work that amounts to bug fixes. It's not 1.2. It is 1.2.1. Because if you keep going down this route, the danger is that version numbers become more about marketing your tools than actually communicating the changes in the functionality, right? And SEMVer isn't about marketing. It's not even about you, fortunately. I know. It's about your users, whoever is actually consuming the tools that you are producing. So when talking about marketing your updates and things, use named releases that are not based on your numbers. A lot of people, at least at Northwestern Mutual, we name our sprints based on some whatever. Right now I'm doing national capitals for my team. That's a great way of communicating that you have released something. Just talk about what you did for the last 2 weeks. You don't have to like muddle with this number thing anyway that most people that you're talking to don't know what you're talking about anyway. So don't do it. Okay, we're gonna move right along because we're about halfway through the talk. So we're gonna talk about NPM and we're gonna learn the whole thing in like 3 minutes. So NPM, it's an ecosystem in JavaScript via Node that manages packages. They call it the Node Package Manager. It takes a config file, which is the package.json in the root of your repo or whatever, and orchestrates an environment for your app. And it uses semantic versioning and version policies around those to decide what to pull into that environment. So when we talk about app on a new machine where you're trying to set up a new environment, it's really important that you're using the same package across everything, the same version across everything. And you need to know that when you pull in bug fixes, you're only getting bug fixes. So we've learned NPM. Congratulations. Okay, so I do want to talk about version policies. NPM uses characters to denote version ranges because if you, as we keep going in this talk, we're going to learn how you could be releasing every single day, which could get annoying if you're trying to consume this and you don't want to constantly update the actual all three letters of your dependencies. So I'm not going to get too far into this. This is mostly just for reference if you're looking at these slides later. And it's useful if you trust everyone. There's a caveat. I'm not going to get into this demo entirely, but when these go out, you can go to, there's a really cool calculator that NPM provides where you can actually see what a version policy that you make will actually map to in terms of what gets pulled into your package lock. We're not going to talk about package lock, but basically what gets pulled into your environment. So follow the link when we get there. Basically, when you have these version ranges, depending on how you set them, you could be pulling in a wide array of things, which is actually why package lock is important. Again, we're not going to get into it. That's not what we're talking about today. Something that you could do is save exact true in your NPM release or your NPM RC file. If you do this, you really need to make sure that you are updating your dependencies frequently so you don't fall behind and then your app doesn't get stale and then your PM is wondering why you are behind. So this ritual of updating your dependencies as you go. So generally, when you're doing this manually, when you're releasing something manually, you basically try to sit there and think about what you did for the last 2 weeks. And you kind of like go around, ask all your teammates on Slack what they were doing, what they were excited about in the last release, and you put that into a change log that you probably send out in an email. And then after that, you got to figure out what version bump to make, hoping that you're not doing sentimental versioning or maybe forgetting about something that you did. You might run tests. Hopefully you're running tests. And then you bump the version to whatever it is. And you're still doing this locally, by the way. And then you run npm publish, it sends it up to whatever you're doing. And then part of that is that you get a new tag in your repo. So you got to push that up to your repo as well. Sounds like a lot of steps, right? Yeah, it is. And crap, you published a change, but then Jen added a cool new method that you really wanted to announce. It makes adoption way easier. You forgot about it. What are you going to do? And you didn't push up your tags for the version bump that you made before you left for lunch. So everyone's been deving on something for 2 hours because you take a nice lunch. And when you get back, everyone's in rebase hell and no one knows what to do. You might ask yourself, why am I spending time doing this anyway? You're right, it's a good question. So there's a tool called conventional commits that really changes the game in terms of the entire workflow that we're talking about. So we go from up here where it's just like, oh, we're refactoring. I don't even know what we did. Some doc fixes with conventional commits. We know that we're doing documentation on the switch for apparently the React docs. We added some new icons. We built, and then we have some chore stuff where we're just merging stuff in. I agree with Drake. This bottom one is much easier to parse, and it's not for us. Maybe it went away. All right. Audio. You know what? The audio was really agreeing with us that it likes the bottom one more than the top. So talking about conventional commits a little bit more. They programmatically generate your change logs. You don't have to do this yourself. They also help you programmatically determine your next version bump. You don't have to do this yourself. You don't have to worry about the fact that you forgot that Jen added that method 2 weeks ago and you just forgot to include it. We talked about a little bit of the archaeology of looking at commits a second ago with Drake. It's pretty nice. It also makes onboarding easier because people just know actually like what is expected of them when they are committing their code. So people can actually start making meaningful commits much sooner. And it's also documented. And it makes make sure that everyone is committing the same, which is really important, especially as you start scaling up your teams. You don't want to be micromanaging anything, hopefully. So what does this look like? We saw the first line in that screenshot where we have the type of commit, the type of change that we made to the repo, and we had a little scope, and we'll talk about that in a second. And then the actual subject of whatever you did. The thing that's not in this screenshot is that first line should only be 72 characters because we want to make sure that we are getting the full nature of the change within the truncation limit of like GitLab or GitHub. Then we have a blank line. We talk more. And then after that, we have the footer, which is where you are mentioning your JIRA tickets, because PMs need to know what you were committing. So do we. You might be thinking examples might help. I agree. So we have a couple of commits. So we have 2 commits here, just to be clear. The first one is bug fix. We're debugging tooltip positioning, and it fixes number 3, which is the issue in the repo itself. So there's that one. And then we also have a refactor for the onboarding, where we simplify the business logic for the onboarding form, right? So both of these are valid, and you'll see, especially with this second one, that it's very simple. It's not like a super long, drawn-out thing where you have to remember blank lines and what goes where. Look, it doesn't have to be that complex, but we have to build for edge cases. We have a couple more. We have a feature. We add a new icon to the icon glyphs, or maybe we expose typography as class names. And again, we have the footer where we close number 3, and then we also close our JIRA ticket, right? So these are just examples of good use. We also have a breaking commit. We'll talk more about this later. We have a breaking change where now all API calls are requiring authentication for requests. Probably should have before, but that's not for me to talk about in this slide. But so this is a breaking change. So all in all, it's about the commit hygiene of what you're doing. And you might be saying to yourself, Josh, you're seriously policing my commit messages all the way down to that? I thought we talked about micromanaging. And I say, it's about commit hygiene. So, so there's a few things that are valid critiques. NPM version creates a new talked about how we're trying to automate all of this so we don't have to do this locally. Fair point. And the pipeline will run in perpetuity every single time a version changes, because that generates a new commit, which generates a new need to run the conventional commit parser. And it also seems like there's a lot of setup. You're right, but somebody already did it. So we have this tool called semantic release that works with conventional commits under the hood. And in their own words, semantic release automates the entire workflow, including determining your next version number, generating the change log, and publishing the package itself, or not, because that's the beauty of it. Leaving this on the screen for a second. There we go. We're done. All right. So what this looks like in terms of what you need to set up in your app, you have a config file that's called the .releaserc. You give it a bunch of information, and away you go. But if you're trying to, I'll talk about this first part first. So with that releaserc file, we can programmatically determine the version number. We can bump it or not. It just runs and decides whether or not to version bump. We generate the changelog, we publish, and then you can actually announce. So the ecosystem will actually announce any issues that you close in GitHub. It'll just make a commit. It'll make a comment saying that it is closed those. It's all in the CI. You don't have to do anything, and just save your receipts. We have published 3.4, and then we had a bunch of chores. There's no relevant changes. Nothing needs to happen. But both of these run in the CI, which is really important. And the changelog is super slick because you might notice that we are collating bug fixes and features. Now, the bold bits, I know it's a little hard to see, but really just the bold bits are that scope from that the earlier slide with the anatomy. And then the subject is what you see there. So, and this is all, again, it's all just generated for me. I don't have to link to the commit message that actually did the thing, and it generates the tags for me. It's fantastic. We also have something that announces to our Slack channel whenever we make a new release so that people know what's going on. And again, this is all based on the lifecycle of semantic release. So on workflow, we use Gitflow, and there's not much that changes here, right? So we have develop, master. Master is a series of merges and tags. We don't do anything to master. Everyone cuts from develop, and we have feature and fix branches for everything that we do based on develop, merge that in develop, and then merge it into master. Away we go. And Gitflow, that's a good link to talk about it. I'm not going to spend much more time here because we're running up on time. Pro tip. So with all of this, because we can release at any time, develop needs to be ready to release at any time. So just this, I didn't actually put this on the slide, but a lot of the importance in terms of the release process goes away from spending time figuring out what changed to making sure that you're testing things to make sure that things are changing as expected. But how can we trust a computer to handle those major version changes? If you're waiting to handle major version changes, and this is like breaking changes, if you're waiting to do that until release time, computers really aren't your problem. They should, breaking changes should not be a surprise. So very the UI toolkit and all of the NPM tools that we publish, we have a deprecation pattern where the important part is that we have 2 to 3 update life cycles that we give all of our consumers before we actually break anything. So it gives them time to actually get out ahead of things. I'll leave the steps up there for a second so you can look at it, and away we go. Major versions, or what they break, should rarely, or if ever, be a surprise. You should be doing things deliberately because you're holding yourself to that social contract that we talked before. Convinced?
Oh, yeah.
Yeah?
Yeah.
Cool. Well, it doesn't matter because you're getting the next bit. So at the very least, if you take nothing else away from this talk, just start committing semantically. You don't need to do any setup at all. It's just a matter of changing slightly how you organize words when you're committing stuff. When you make a new tool, start at 1.0 and just go from there. Hold yourself accountable as you go. And stop calling things 2.0. It hurts. And save exec true. It's helpful. Should you version your app? Probably. It makes debugging easier. Change logs are pretty slick when you're reporting about what you did for the last 2 weeks. It makes PWAs a little easier to handle lazy loading because you have a version that's meaningful and stuff like that. The Q&A, tell me if I missed anything or you're not convinced. Again, at the very least, you should be doing conventional commits. I'm at 20 minutes, so I have a little bit of note on tech setup, but we don't have to talk about it. Just for if we're recording it all, this is on the screen. We have some drawbacks. Mono repos don't work very well. Should probably be its own repo, but we have shareable configs to deal with that. You technically are committing more, but that's probably for the best. And we have linting. Sorry, okay, I'm going to stop with linting because this just enforces the rules, but I would like to respect everyone else's time that's presenting tonight. So very quickly, if you work for Northwestern Mutual, we have release configs that do a lot of this stuff for you, so you don't have to do it yourself. We have an example repo called UATK fonts that does all of this, and we have utils for doing this. We also have a blog that talks about it. Thanks, everybody. Okay, I don't know if we have any time for Q&A, but I have a slide for it.
Okay, let's pull that up. I brought you a water.
Oh, thank you.
You're welcome. So we're just going to pull up a slide for Q&A, and remember, if anyone has a question, we're going to do the Twitter hashtag, so just hashtag ReactJS United. So in, I lost the people there. So in Chicago, Denver, so how about here in Milwaukee? We can do some in-person questions. So we're just going to repeat the question so everyone can hear it before you answer it.
With the mono repo, can you do each piece of it? Each repo has a mono repo with some version?
So you're meaning, so like if you have multiple packages in the same repo, this breaks down because the semantic release package is just looking at what commits you made. Haven't found a question back.
I was wondering, you had a slide up where you had a branch, and you said you never merged back.
Only merge back to master. So the question is, we have develop and master. Just to clarify, for master itself, it should not be getting individual commits. It should only be getting merges from either a release branch or from develop itself.
Okay, I thought you never merged.
Oh, yeah.
Right. So can we just repeat that last question, and then we're just going to allow one more question here. And again, hashtag ReactJS United. You guys can ask as many questions, and we're just going to move to the next city.
So the question was just, making sure that we are accepting merges to master. The confusion was that I might have said you never merge into master. That's the opposite. You only merge into master, only throw. You got one in the back.
What's your favorite Drake song?
Favorite Drake song?
What is Josh's favorite Drake song is the question.
Probably a little basic, but probably Passion Fruit.
All right, so Chicago, do you guys have any questions?
Seem like it. No, it does not seem like it. Thanks.
No questions from Chicago. All right. How about Pittsburgh?
All right, so we have one question from Grex. What are your thoughts? Milwaukee?
Hey guys.
Milwaukee?
Hey guys, we're still running the Q&A. Sorry.
I'm gonna have to get my mom face on here. What are your thoughts on Lerna as an alternative to semantic release that supports mono repos?
So Lerna is great. I do think that, so Lerna, my understanding is that are under that mono repo as the same version as you go. If I'm wrong, definitely call me out on that, but that's my understanding. So you're not necessarily communicating the changes that are happening in individual packages. And then on top of that, I don't know, like we've never run into a situation where Lerna is a better solution than just having individual repositories that manage a package and just having those all locally.
Okay, great. Well, thank you so much, Josh. Woo! so now we're going to turn it over to Justin in Chicago.
Where did Zoom go?
So just stop sharing.
Stop share. And full screen this bad boy. All right, Justin, take it away. We're gonna chat.
Yeah, let's just see here. Okay, no, that's it.
Thanks.
Yeah, no, thank you. Maybe just take it. Okay, sorry.
Sorry, guys, one sec. Looks like I had to quit and rejoin. Sorry, guys.
Do I need to? Which one? This one? Is this too bad?
Should we go? There we go. Yeah, I think so, right? Okay. All right. I don't know if people in other cities can hear me. Hopefully so. Yeah, good. All right, cool.
Good.
All right, so I am Justin. I am one of the client-facing engineers here at Seed. I work on JavaScript and React stuff. We do a lot of different things with JavaScript. So today I wrote a React app that uses the Ethereum blockchain as the backend instead of the traditional tools of like Postgres, Mongo, Auth0 to kind of build up the functionality you need. So kind of first, this is what a lot of people call like a DApp or like a distributed app, which that really just means an application or solution that's like built on a decentralized ledger instead of built with like the traditional tools of SQL databases and, you know, Auth0 and all of this sort of stuff. And right now, this isn't really easy for consumers to use, and it's not really easy to build. There are a lot of hurdles, which is why we're not using these like in the wild yet. Really, the public doesn't know how to use them. People need wallets. They need to know how to send transactions. They need to manage their own private keys. And so we're still kind of in the infancy of decentralized apps, but I think that it's a big opportunity for us as JavaScript developers to kind of be ready for the next thing and make sure that like we can all cash in if this skill ends up being in high demand. Also, I think the reason that this really hasn't taken off here is that we don't need it yet. We have centralized apps that work awesome. They're super fast. Postgres is great and it's free, and this is neither of those things. But it offers some stuff that if you need that decentralization, you need that trustlessness, you can do it today with tools that other people have built. So I think web is going to be the entryway for a lot of people into these sort of apps, into like working with blockchains and getting familiar with them. Right now, there really isn't any native tooling on iOS or Android to get set up with wallets to, kick off a transaction to a different app. But the web has that stuff now. Now we have libraries, we have extensions. There's a lot of tools that people have made to make it easier for us and easier for our users. And so it's possible. It's not super easy yet, but I think we're getting there. And I think the web is really going to lead the way. Eventually, I think phones and operating systems will have to come with that functionality native because that's what people expect. So hopefully we'll build it and then they'll have to match it. So jumping right in, I built this React app. It's very similar to a kind of full stack application that it's like one repo. It has a React app, it has some backend stuff. there's like a data tier, there's like a middle tier where you'll get your data out, get your endpoints, access control, all that sort of stuff. It's pretty simple. The premise of this application is it's like someone can propose something to be voted on. So I have this smart contract, anyone can go there, it's public, they can instantiate a new version of this contract and say like, I want a public vote on this thing I care about. So for example, today, like, should we get more pizza? That might be a thing that I want you all to vote on. So I could come here, instantiate this, send it all out, and then we could have like this voting that's on public record. Everyone can participate. No one can be kicked out. No one can govern it. Yeah, that's it. So it's pretty simple, but let's jump right in. So first, how you write the back end of Ethereum contracts is in Solidity. It's a programming language. We write smart contracts. A smart contract is kind of a combination of like the data tier and like the middleware tier where you get out that data. So for example, this contract is how everything gets saved, all the logic for like the state, and then also the methods to get this stuff out. So up here at the top, we've got some like declarations of variables, you know, ints, strings, pretty standard stuff. We have this initialize function, which this is what gets called when you actually initialize it. And the thing that you pass in is like the address of the official, the person who's going to officiate this vote. So then from there, you've got a bunch of getter methods that really just return the internal properties. And then you've got some methods to like change the state. So like these are like vote or, you know, tally votes. And this actually will like interact with the blockchain when you invoke this method and then do what it's supposed to do, whatever the code says. And then that will be persisted and saved, and that's there forever. And I think that's super cool. So this is written, and this is just one folder called contracts inside my repo here. So the other folder that we're going to talk about is client. This is a React application. It's create React app in its entirety. Just super simple. It's one page. App.js has pretty much all the functionality besides some Vue stuff. So kind of the beauty of this is the part that you're not seeing here is there's like all these sweet tools that people built so that we can make solutions that end up in JavaScript just being a promise, like any other promise, where you can say, hey, go to the blockchain, get the data and give it back to me in a way that I'm really familiar with and I'm used to working with. It's like hasten to wait, any JavaScript promise. So how I actually got to this point of being able to do this is I used a CLI made by this company called Zeppelin OS. They provide a bunch of tools on top of this other tool set that lets you, from VS Code or whatever IDE, write your contract, run some command line arguments, send that stuff out, get back the data, and then like hook it up and like get it to work. So that someone like myself who's not super like blockchain knowledgeable and doesn't really know the underlying stuff can just like have it work. Like it works like Webpack, where like I don't even know how it works. I need to read a documentation and to make a JSON config file, and that's it. So that's what happened, and that's what I've got now. So this is pretty much it. You've got your getters and you've got your methods. It renders out some stuff, some buttons. So let's see what it actually looks like. So this is hosted. It's up at justin.dev. If anyone has Ethereum and has MetaMask and wants to interact with this contract, you can do it right now. So when you see this website, I'm going to load it, and it just looks like any other website you've ever seen. But the part that you don't see is that this data that's coming from there is like from the Ethereum chain, like for real. Like there's no database involved. It's all out there. So here, I am the officiator of this contract, not on this account, but on my ballot official. So reload this page. So because I'm the admin, and this is like a stateful bit of code, there's access control built in, there's all that sort of stuff. So I can update the name of this contract, like should we get more pizza? Okay, so I'm gonna update that. That's the name of this ballot. So now here's what's happening is instead of like Postgres or Mongo, where I would go like right to my server that I own, what I'm doing here is like alleging a transaction like to the Ethereum chain, and the contract is going to check the ownership and know that like I have access to do this, so it's going to work, hopefully. So here, let's do this. So now I'm going to pay 3 cents to send this. I'm actually going to pay 10 cents to send this because that's how Ethereum works, right? It's like the Ethereum blockchain is commonly referred to as like the Ethereum virtual machine. It's a bunch of code. It's a bunch of state that you can write to and you can read from. And when you write to it, you have to pay a little bit so that the people that run the nodes will run your code and do the stuff you want them to do. So what I'm doing here is I'm incentivizing someone to run my code quickly. I'm gonna give them 10 cents. So here we go. Let's kick this off. So now that's kicked off and it's gonna take a little bit to process. But when that does, this page will update here with the new name. It'll come up here at the top. And then that's it. That data is on the ledger forever. So then the other kind of functionality here, we'll let those transactions confirm and come back. Here we go. So check it out. So now like, that's real. I kicked off a transaction, I paid for it, it persisted. Now the name of this is, should we get more pizza? So that's cool. So that's the question, should we get more? So then to kind of illustrate the user sign up bit of this, kind of like any other React app would be, like you need data, you need access control, you need to be able to write. So here, people could come here, view my thing and be like, man, I feel strongly about this. We should definitely get more pizza. So they can register, which I will do. There we go. Gonna make this go fast again. So now as I'm registering to vote, you can see that someone's already registered. Somebody here, actually one of my buddies, to make sure this actually worked. But then when this comes back, it's gonna update the public state of this contract, just like you update a database row, saying like, hey, now we've got 2 people. So that will do that. And then kind of the last bit of this is the admin, which I'm logged in now, has these admin actions. But if you were a different user, for example, you switch to a different account. Reload this page. Okay, so the voter came back. Now we got 2 people registered. My other account, this account's not an admin, so I can't do anything, but I can register again. So let's go this one, J2. Let's register. So then what I'm gonna show you guys here is I'm gonna open the voting period. Then people can vote, and then the admin can end the voting period, which will then take some of the private state variables of that Ethereum contract and make them public. So it kind of illustrates like you've got this business logic that you've set up. It can do the things, you built the hooks, and then just kind of let it work. So I'm gonna show you how this works in the contract while I wait for these things. Actually, let's kick off our, so we'll start our voting period. All right, while it's kicked off, let's look at our contract here. So really quick, when people vote, we've got a map here, this votes array. And then we also, if the vote was yes, we add it to the count result, which is the yes answer. So then at the end of this, we're gonna compare total votes, yes votes, so we know how we did. And then the end vote function, all this does is take the private class member and then assign it to a public class member. So all this sort of built in Ethereum, it all just works. And yeah, relatively simple. So now let's see. Looks like we're still waiting, which that's kind of the beauty of it is it's not super fast, and it sometimes does take time, which is why there aren't great solutions built on this. Let's see if it goes yet. Okay, well, once the voting opens, I'll click the button, and then we'll wait for that again. So let's talk a little bit about how this is set up. So this project now with Zeppelin OS comes with like a lot of sweet tools for web developers like us. So when you're developing your contract and your front end, like normally people use like Webpack, Hopperload, stuff like that. You get that with this. So you've got 2 different files open. Back end with your file, your front end, you're hit Control S. It goes over, deploys your thing in the network. And so now we've got this like familiar development experience with this tool set. I think really help people like us grab hold of this, learn it, and start to take off. All right, we going here? Okay, all right. So now voting period is open. I'm gonna vote yes. Same thing. And then I'm going to go to my other account, and I'm going to vote no, so that we've got a little, when we pull the results, you can see what's going on. So then what's actually happening behind the scenes is this plugin, MetaMask here, is a wallet, and then it provides an instance of this library called Web3 to the actual web application. So then from there, I'm able to like put in the address of the contract I want and then get the stuff back. And then when I go to kick off a transaction, I don't have to worry about that in my React code. This plugin handles it all, this extension. So then I like give it a payload it expects, it knows what to do, it kicks it off, and then it's really abstract away from me as a developer. All right, so now here we go. This guy, let's vote no. Oh, there's 2 people vote. Let's see, I'm gonna vote no now. Last one. All right, and then finally, let's switch back to the account of the official for this. End of the voting. See the results, and that'll be it. Okay, here we are, back. So you've noticed these transactions cost between 10 and 20 cents each, and that's it. You know, that's what it costs to like develop and like work with these things. I think that's probably. I think that's a fair price to pay because the alternative is hosting servers and doing all that sort of stuff. Whereas this, I wrote this contract, I deployed to the mainnet, it's going to be there forever. Like I don't have to worry about maintaining a server. So in 10 years, if someone goes to this website, it will work probably because like I don't have to maintain it. It's out there. The data's there forever, which I just think is so cool. All right, so here we go. Now we got 3 people registered. Oh, third vote came in. Let's end it. Let's see what the results were. Something here. Save it. Take off our transaction. All right. So now, wait. But this is something that I am interested in because I think that this is the future. And I don't think that it's going to be coming in the short term because I don't think as like Americans and people with like stable fiat currencies that we need solutions like this right away. I think they're kind of impractical at the time and expensive, difficult to do. But I think that sooner or later, this is coming and I want to be prepared for it. And I think that as JavaScript developers, like all of the tools are around our familiar area. So it's a great opportunity. So let's see what we got. So you can see here, my vote's been in, but still waiting for the transactions to confirm. So since these are Ethereum, since these are transactions on the Ethereum chain, you can just view these on Etherscan or whatever other tool. So this is the actual transaction. So it's from my wallet address. It's to a contract, and it's probably confirming on its nodes right now, and then it will come back. Here we go, 6 cents. So now if we go back to our page, all right. So apparently everybody voted yet. So that's it. You should get more pizza. It's confirmed now. We've got it. It's public record. Let's go. So that's it. React Ethereum. It's hard, but I think it's worthwhile, and I think this is definitely the future. You guys should all win. Thanks. I don't know if we're gonna do Q&A.
I mean, any questions? Anyone have any questions?
Just
Just remember to repeat it.
There's this one quick one for asked. Can you talk about the MetaMask GitHub or the plugin?
Yeah. So the question is, I talk about MetaMask. So MetaMask is.
You had already referenced it.
Uh-huh. Oh, MetaMask is it? Oh, MetaMask is Web3. So Web3, like just WP number 3. And Web3 is like the standard. It lets you get data from Ethereum in a really simple, familiar JavaScript way. And then all sorts of tools you can do serious stuff with it. Stuff I do very light and just like give me some data, send some data. But, yeah.
So my question is, I heard a few things. Ethereum virtual machine. I heard you're not using let's see, you're not using database, you're using the Ethereum blockchain as a database.
Mm-hmm.
What list of GitHub utility have you kind of collected to put this working model together?
Okay, so the question is, like, what is there a list of repositories and things that are helping us build building? Yes, there is. I don't have it off the top of my head, but this repo is public, and I'll share the details of that. I can post this on the meetup group. But yeah, there's a lot of different tools that have come help me do this. I don't really know a lot about blockchains. I know about JavaScript and React and whatnot. And that's
Okay, so we got a Twitter question. Can we do that real quick?
yeah.
So what browser plugin was handling your crypto accounts?
So the browser extension is MetaMask. It's kind of the de facto standard for working with Ethereum in the browser. They are pretty well established now, been around for a bit. Highly recommend them out. All right, in the back there, first and front guy. You in the, yes.
So how do you go about
No. So what I did, you can run a local blockchain. Oh, sorry. So the question is, what did I do to develop this application? Did I pay 20 cents every time I wanted to make a code change today? The answer is no. It's a local blockchain. It's called Ganache or Ganch. I'm not sure how to pronounce it, but it's part of the software suite under the Truffle. So Truffle makes a bunch of tools to work with contracts and Solidity. So then this is my local blockchain. So here it is. When you fire it up, it gives you some accounts. Each of them have 100 ETH in them. It gives you the private keys of those accounts so that you can interact and do stuff. And then the Zeppelin OS, which is the other CLI I use that bolts on, it does all the work. Like I literally just write the contract and save it, and then it deploys my contract and refreshes my React app, and I just get to develop. I don't have to like worry about it. And then when it comes time to develop to like mainnet, then I'm doing it from the CLI. It's a bit manual, but this is the first time I did it, and it seemed to work out fine. Question was, do you have to pay to read, or do you only have to pay to write? You do not have to pay to read, but it is very difficult. It's like you have to like TCP, like it's like super technical. I don't do that. What I use is a third party, like one of these tools. It's called Infura, INFURA. And what they are is like some people call it like second tier like blockchain. It's just a regular API that we're used to, like REST API. And then you go in there and make an account and get an API key. And then that way I can come into my JavaScript code and then just do something like, oh, that's not JavaScript. Do something like this, where I say, hey, give me the instance of the contract. And I pass in the address, and then it calls a endpoint over REST. And then they abstract all the technical stuff away. I get it back as JSON, and that's what I do.
How many questions we get to?
Yes, yeah. So the question was, were there any business cases where the company like covers the cost for people to transact with the blockchain? Absolutely. So that's one of the hardest problems of like developing decentralized apps is like there's no users. Like people don't know how to do this yet. And so the big problem is like, where do people get their first Ethereum or their first Bitcoin? Like right now, there's a lot to do that, having a wallet, private keys, whatever. So there are companies that are providing solutions that are trying to ease that friction. A company named Portis, I believe they're from Israel. They are developing like user interface tools for JavaScript developers to get people ready to transact in the browser. So like what they provide is a super nicely written interface, or I'm sorry, API to be like, hey, sign the user up, and you just call like, you know, whatever, portis.signup, and then it pops up a modal, it has them enter a password, and it kind of like walks them through it. So then at the end of it, what you get is that Web3 instance, which you can get from MetaMask and the others. So then like behind the scenes, your app is the same, and it doesn't matter if they came from MetaMask, Portis, whatever. And then with Portis, to answer your question, there's an option where you can put in like your own address so that you can cover the cost, so that you can ease the friction of like, oh, you want to get like a sticky onboarding experience. You let your customer come on, you let them transact, like see the value of it before you ask them to like, hey, start managing your private keys and sending us Ether, you know? So I think that, yeah, that's a big problem, but people are starting to tackle it now.
All right, let's give Justin a hand.
Thank you.
Denver now.
Thank you so much, Justin. That was awesome. And now we are going to throw it on over to Denver. So everyone want to take a seat? Denver's going to get started now.
Okay, Denver.
So Milwaukee was having trouble hearing you, but the other group wasn't. So
Really?
she was saying you're muffled. I was like, well, you guys are muffled too.
Yeah.
Also, while we're kind of doing the transition here, we do have the survey. So for all the cities, it's a bit.ly link, and then /ReactJS United -1. So Carrie, did you fill out your survey? ReactJS United -1 bit.ly link. So this just helps us get an idea of what you guys like, what you don't like. So everyone out in Denver, Pittsburgh, Chicago, if your audience is up for it, just filling that out would be awesome. And it's about 4 questions, so easy peasy.
You know, I just turned my volume down, so I am.
You guys hear us on the stream? Give us a thumbs up if you can. Good? All right, we're gonna hand it over to Sharon here.
I'm all set. Hopefully I don't spill water. All right, here we go. Nope, that didn't work. Let me try this again. Okay, well, hello everyone. I'm here to talk about Redux custom middleware. This work, awesome. Ooh, hold on a sec. Yeah, better. All right, so I work for Workday in Boulder. Absolutely love it. Super fun place to work. I work with our very own Will Klein, who convinced me to come out here and give my very first meetup talk. So I'm a little nervous. So bear with me. Yeah, and I'm going up right before Ryan Florence, who is a professional speaker. So I'm going to try to, I had free lunchtime yoga, courtesy of Workday today. So I'm going to try to channel in that Zen, slow down and make this happen. So yeah, this is about me. And when I'm not here at work, this is what I spend the rest of my time doing, is dealing with this guy who's reading a book about how to deal with this guy. All right, let's keep moving. So today I'm going to discuss what is middleware. off-the-shelf middleware, how to implement middleware, some action processing patterns, and layered architecture using custom middleware. So here's a simplified diagram of basic Redux. We have an action object that we pass to the dispatch function. Redux framework takes over and passes that action onto the reducer function, which is your function that updates Redux state. And that uses Redux state. So what is middleware? Well, middleware is simply a function. The Redux framework provides an extension point where we can inject middleware into a chain of functions. This chain begins with dispatch and it ends with the reducer. This chain is often referred to as a pipeline, and you can kind of think of it as a pipeline to flow through. So middleware has the opportunity to execute logic in response to an action after the action's been dispatched and before or after an action is processed by the reducer. We'll explore how this works in the upcoming slide. So why use middleware? Well, React components should be focused on presentation logic. Reducers should be pure functions focused on managing state. Actions are simply messages with data. So where should we put our application logic? How can we perform side effects? Where should we make asynchronous API calls? Middleware is a flexible solution for all of the above. And the Redux, straight from the Redux docs, it says, people use Redux middleware for logging, crash reporting, talking to an asynchronous API, routing, and more. So let's talk really quickly about some popular off-the-shelf middleware. You've probably heard of Redux Logger, which is super handy, logs all actions to the console log. Redux Thunk is used to achieve side effects. It executes actions that are sent as functions instead of objects. Redux Saga is also used to create side effects, and it uses ES6 generators to manage a series of asynchronous calls. There's really an incredible number of off-the-shelf middleware out there. Here's a link to Mark Erickson's blog. He's got just a collection of hundreds of off-the-shelf middleware categorized. Very interesting. But I'm not here today to talk about off-the-shelf middleware. I really wanted to talk about writing your own custom middleware, because it's really not that hard. So here's the code for a bare bones custom middleware. This middleware does nothing but participate in the pipeline. The function signature may look a little intimidating, but not to worry, only the Redux framework is going to call this function. Oh, and your unit tests, they'll have to call it too. But we'll cover that on the next slide. So we see here, excuse me. Okay. So we see here that, sorry, I don't have a laser pointer or anything, that yeah, custom middleware is really a nested set of higher order functions. And a higher order function is simply a function that returns a function or takes a function in as a parameter. So this is a higher order function that returns a higher order function that returns a higher order function. So let's walk through these function parameters. The store API is simply the get state and the dispatch functions. Next is the function that we execute to execute the next item in the pipeline. And action is just our action object. So here, my bare bones custom middleware, all it's doing is calling the next function and passing it the action flowing down the pipeline. Down here, we have the TypeScript definition, which is the exact same function definition. It's just got all the types on it. Isn't it nice? I love TypeScript. So you may be wondering, how do I unit test this thing? Well, actually, it's pretty easy. So first we set up our mocks. As I said, our store API is just dispatch and get state. We create a mock for the next function. Then we create our action object and we create our middleware. And then you call it. You call your middleware passing our store API mock, the next mock, the action object, and then we can run our expect statements. So using the bare bones example from the slide before, we expect next to be called with the action object, and we expect the store API dispatch not to be called at all. All right, so here's an example of custom middleware that takes a configuration parameter in the initial function. This way, we can configure or customize the middleware at its creation time. This middleware is a little less bare bones. It's going to actually log the console action before sending the action down the pipeline. In this case, there's a log as warn configuration parameter. And based on that, we're either going to log the action using console warn, or we're going to log it using console log. All right, let's look at a more complex example. So the first thing this middleware does is use the store API to retrieve the current Redux state. At this point, the action has not reached the reducers yet. Next, it sends the action down the pipeline where the reducers will process the action and the store will be updated with the new Redux state. Now, the middleware can call getState again and retrieve the new Redux state. This middleware is simply going to console log the old and the new state, but more sophisticated middleware like Redux Logger would do some diffing and create some fancier output. So this is quite a powerful feature that we've just seen. Just like recursive functions build up on a call stack, the functions of the Redux pipeline also build up on a call stack. So middleware has the opportunity to execute logic as the call stack is building up, as well as when the call stack is winding back down. This is how middleware can do work before and after an action is processed by the reducer. So let's look at a real world example. This is a middleware code for Redux Func, and it just happens to be ridiculously simple. So if the type of the action object is not a function, then we just send the action down the pipeline. However, if the action is a type of function, then we execute the function, injecting dispatch getState, and I don't know what the argument is, and then we return the result of that action function. So this is really interesting. This is a different pattern than we've seen before. When the action is of type function, then we don't send anything down the pipeline. The action never makes it to the reducers. The execution of the pipeline ends here and then rolls backwards. So this is a good segue into my next topic, action processing patterns. So middleware can do whatever they want with an action. They can swallow it, as we just saw Redux Func do. They can delay it, transform it, modify it, replace it, you name it, they can do it. So there's a lot of flexibility here. And like reducers, middleware can selectively handle some actions and ignore others, just pass them down the pipeline. This is a nice visual I found on the internet. This is from Saad Hassan's blog. And I'm not going to speak to all of these patterns, but I can speak to some of them. The first one, filter, we just saw in Redux Func. Redux Func filtered out any actions that were functions, filtered that out from the pipeline. Another popular one is split. You often see examples of web apps that have a fetch data action, and it gets split into fetch data success, or data error. Enrich and normalize, we're going to see in an upcoming example. Enrich is when a middleware adds info to an action payload. Maybe it's static data, maybe it's information from the Redux store, maybe it's from an API call. And normalize, well, normalize is a loaded term, but here I interpret it to mean taking action data of different shapes and converting it into a specific shape. All right, so this brings me to my last topic, layered architecture using custom middleware. So the classic definition of a layered architecture usually says, all right, you've got a presentation layer. In React Redux, obviously, these are the React components. Then you will have a layer to represent your business logic, or sometimes they call it a model layer. You may have a services or API layer, and maybe you'll have a persistence or a database layer. But layers are not really limited to these examples. You can create as many layers as you want, as many layers as seem appropriate for your app. And as I look for creative ways to use custom middleware, I see that middleware is really a natural, good fit for implementing layers in a layered architecture. So let's look at an example. We'll use a collaborative text editor for our example. So imagine it's a web app hosted in the cloud. It's got a centralized server backend that relays messages about everyone's edits. We can allow multiple people to edit the document at the same time, and everyone's edits are shown in real time. So something like Google Docs. All right, so in this collaborative editor example, I will have 4 middleware modules, each with a set of responsibilities, and each module will represent a layer in my layered architecture. The first module is the initialization middleware. It could be responsible for general app initialization activities and making API calls to the server to gather initial data. Next, we can have a remote edits middleware. It could be responsible for processing WebSocket messages from the server and normalizing that server data into our client model objects. We can have another one, local edit middleware. It can be responsible for processing actions that are dispatched from React components. Maybe it'll make the API calls out to the server to say, hey, a local edit has been made. And it will also normalize the request data into client model objects. And then finally, we can have an undo redo middleware. And it could be responsible for determining the undo of a particular edit and perhaps creating the undo redo transaction that will sit on our undo redo stacks. So let's walk through a couple of scenarios. The first scenario is opening our web app. In this case, we have a app component, and the first thing it might do is dispatch an initialize action. And that action will flow through our pipeline. It'll get handled by the initialization middleware, as we just spoke about, and enrich that payload with all the data gathered from its API calls, and send that action down the pipeline, where next it'll be handled by the reducer to put all that data in our Redux state. Another flow would be inserting text. So perhaps we have a text editor component and the user types some text. Then the component can dispatch an insert text action, which flows down the pipeline and is handled by the local edit middleware, as well as the undo redo middleware, which both enrich, normalize the payload of the action, and then finally sends it to the reducer to be stored in the Redux. And finally, my last flow would be the remote edit case. So in this case, we've initialized a callback for our WebSocket messages from the server. And that callback is going to dispatch a remote edit action. Use this remote edits. So this flows down the pipeline, and much like the previous flow, is handled by the remote edits middleware, as well as the undo redo middleware before flowing down to the reducer. So this is what it looks like when you put it all together. So what do you think? Are you completely baffled? This is a far cry from traditional Redux architecture, and you're not going to find an example like this anywhere on the blogosphere. This is a different approach from spreading your logic out over components, action creators, customizable middleware, large reducers. Using this approach, I would hope to avoid having business logic in the React components, which everyone knows is good practice, and also avoid having logic in action creators, which are often called by React components. I would also hope to minimize the amount of logic in reducers, keeping the scope of reducers to updating state in an immutable fashion. So I would expect to put most of my application logic into layers of custom middleware. This way, I have a framework where I know where to put my application logic. So what are the benefits? I like this idea of creating distinct modules that have specific roles and responsibilities. I think it further achieves separation of concerns in my app. It keeps related code isolated and co-located in my module so that it's easier to understand and easier to manage. I like providing a clear structure for finding, updating, and adding code. This way, developers can add new features quickly and easily since developers know where to put specific pieces of logic. And finally, having boundaries, clear boundaries using middleware makes it really easy to mock and unit test, as we've already seen. So that brings me to the end of my talk. I hope you enjoyed this food for thought, and thank you very much for listening.
So I just want to kind of point out real quick, I gave Sharon probably the lousiest introduction I've ever given a speaker, and she absolutely crushed that talk, which was her first talk. So give her one more round of applause, please. That was great. We're gonna get set up here, get Ryan set up, and we'll be back with you shortly. Stay tuned.
Oh,
yeah,
one of those.
goes like that over your
Yeah, I get
cancel.
it.
And the mute, it's muted right now, but the switch is just on the top there.
Does that feel all right? Guess. Seems like it would be lower, like down on the neck, but is it? And I think it's all wrong.
And then did we get you on the TV or? I don't think
We're
we
gonna
messed
put
with
his slides. So he's
Yeah, I don't
gonna-
think.
I don't have slides, it's just my screen.
Oh,
Just a
okay.
screen.
Yeah.
How do
Here,
we want to do that?
I got it.
He's gonna do Zoom.
Yeah. Okay, so you're on there. Are you sharing your screen already? Or no?
No, I can just share the whole screen and we're good.
Yep. Yeah. Do that. Yeah, and then let me hook you up to our TV.
They were having trouble hearing us.
It will be fine. I'm just saying. Well, yeah, it was actually. All right, so you should be good. Do you see? Yes, you're good.
We're up and running.
All right. Okay, are we good to go? All the cities, can you still hear us? I know we had some technical difficulties last time. Give us a thumbs up or a thumbs down if you can or can't. Okay, well, we're seeing thumbs up, so we're going to go for it. But again, thanks to Sharon for that wonderful talk on middleware. We really appreciate having her give her first talk on a high pressure night like tonight. Well, that's a lot. So yeah, and it just sort of came up that Ryan and Michael were going to be in town tonight. So we're super thrilled to have them kind of capping off the night for us. And yeah, I'll let him do the rest. So please welcome Ryan Florence, everybody.
So this mic is, oh yeah, it is. There we go. It's working. Excellent. And I assume I should have myself muted in the Zoom chat? Okay. Okay, cool. 15 minutes. 15 people left. They ate the pizza and then they left. That was rude. What's it look like in the other cities? Do we know? Can they like tell us what's going on? No one left there. Milwaukee, is it just like the organizers in Milwaukee?
No.
Okay. In Denver then. I don't know if I'm coming back. I'm just kidding. So Michael and I are on a workshop tour. We've been at this. This is our 5th week. 2 cities a week, 10 cities. So we're done in Seattle at the end of this week. So where are we? We're in Denver, going to Seattle, and then we're done. So it's been a workshop all about hooks. So we've been looking at React from the ground up, just thinking about what does React mean now with hooks instead of classes as the way that we compose our UI together. And so if you're interested in it and you missed the tour, I mean, I guess you could hurry and buy a ticket and fly to Seattle with us tomorrow night. But otherwise, you can sign up for our wait list, and we're going to be actually recording the whole thing. We've got a lot of practice after 10 cities. We know what questions people have. We know what kind of misconceptions people have now. There's a lot of stuff that we've learned about how people are understanding hooks that we didn't get before. We've now been in front of 400 or 500 people talking about it. So you can sign up with your email address for the wait list, and we'll email you when that is ready. Oh no, we've got this thing automatically checked. We'll have to go and fix that. But anyway, you can also sign up for the newsletter. If you don't sign up for the newsletter, we will never bother you again. We'll email you about the workshop once it's online and then leave you alone. So yeah, that's what Michael and I have been up to for this talk. I'm just going to take a little chunk of our workshop and do it in here. So this is what we call demystifying hooks. Sometimes we look at these new hooks and kind of think, those feel a little bit magic. Anyone feeling a little bit that way about hooks? Like, I'm just going to trust the React team that they didn't jump the shark on this one. And so what I like to do here is just kind of help us to see that it's not that interesting. What it allows us to do, the composition that these hooks give us, is incredibly interesting. But some people have been getting hung up on how did they implement that? It must be terrible. And so just kind of want to like show, well, here's a really kind of crummy version that we could create of use state, just to kind of get an idea about the mental model. So again, this isn't exactly how React has implemented hooks, but it's got all the right little pieces. It smells like it. So here is my app. Since it's a React app, everything that Dan Abramov has ever done has prepared me for this moment, and we've created a counter. But this one is part of a workout app, and so you're saying how many minutes you worked out. That's why it says minutes right there. But we've pulled it out of the app. Our whole workshop is in the context of this full-blown workout app that tracks workouts and things like that. It's kind of fun. Real-time data with Firebase. Anyway, so this is just a little part of a form that we've pulled out. But it's not just a counter. It's also got a little error message, although the styles are pretty bad. Any boot camp grads in here? Anyone still in boot camp? Yeah. I'm going to teach you something that your instructors have failed you on. Here it is. Here's the paragraph tag, right? This is all wrong. Center. It gets better. There's a whole world of the internet that you missed. Wait for it. Hey. And that's my talk. Thanks for coming. We'll see you later. The blink tag is deprecated. However, it is part of the JavaScript spec. So here I am in Node, like, wait, what do you mean? You can call blink on a string, and it'll wrap it in a blink tag. That's in Node version 12. Don't know why. It's part of the spec, so it's there. JavaScript is backwards compatible always. It seems like Node could have left out that part though, right? I mean, the web can't leave it out because there are blink tags out there, but that's true. Yeah, they just bring in V8, so it'd be more work to remove it than to keep it. Does anyone remember the, I only got 15 minutes. We're fine. Do you remember there was like a video game thing of like a train, and then they actually just made a train a guy's head, like a model's head, because that was easier than like actually making us, like, anyway. Their buildings couldn't move, but people could. And so they needed a train to move across the background. So instead of teaching the buildings how to move, they just like buried a guy in the ground, made his head a train, and then like slid him across the screen. I need to look that up. It was hilarious. Anyway, so your code in production is not worse than anybody else's. Okay, so what were we doing here? Use state, that's right. All right, see you later, use state. We're gonna make our own use state. All right, let's check out the signature here. Use state 5, so we pass a 5 in there. All right, so that's gonna be the default state, right? So that comes in, and that'll get returned to us, and it's actually returning an array here, so it's gonna return 2 things. So we've gotta make an array that holds 2 values. Any super nerds in the room want to give me a name for an array that holds 2 values? Triplet? Come on. Yeah, tuple. I think someone said tuple. That's impressive because that means you've only ever read it, but you've never heard it out loud. Yeah, a well-read man back there. I used to say chassis. I was talking to my cousin when we were building our computers as little kids, and I'm like, yeah, what kind of chassis did you get? And he's like, it's chassis. All right, so we're gonna put our default state in the tuple, and a second one comes in here called set value. So that's the function that they give us here that allows us to update the thing later. So we're gonna make a set value function here. Don't know what it does yet. Then we'll return our tuple. Actually, I really like the way that Michael pronounces this. Every time. And he's not kidding, I make him say it in every workshop. And I loved it. It's part of the script. It's half stand-up comedy, half code. It's one of our jokes. All right, I'm gonna save this. It should still work. Cool. Well, it doesn't work, but it doesn't blow up either. All right, so there's our to-play. All right, so here, let's actually look at the app. Here's the app. We've got 2 use states, one for minutes, one for the error. When we click the add button, we call handle add, And if we have a valid number in there, then we'll set the minutes to minutes plus 1 and clear out an error just in case there was one. And then, of course, if we try to do an invalid value, like down here, oh, that's right, it doesn't work, then we'd set an error. And then we just throw all that stuff at some elements down here. Okay, so let's try to make this part work, set minutes. So I'm gonna get my new minutes in here. And then I need to do 2 things. I need to assign a new value somewhere, right? So that the next render, we get that new value. And then I need to re-render everything. Re-render, that's what set value does. It changes some values, a value somewhere, right? And then it causes the whole thing to re-render. But the thing with these function components is that React called minutes before, right? It called minutes to figure out what element do you have in there. And then took that element and committed it to the DOM on the first render. It figured out, okay, what do you actually want me to render here? On the next render, it's going to call it again. It's going to call minutes again. So then it's going to compare these 2 things, and it's going to get a diff out of there. And it's going to actually commit the diff. So whatever changed between the 2 renders. The thing is, between these 2 renders, these are totally separate worlds from each other. We call minutes once, and we have a whole bunch of variables living inside the scope of that function. Then we call it again, or React calls it again, and it's a whole new scope. This function has its a whole different world than the previous render. We're not used to this because we're used to our class components where things like this dot state kind of stuck around, right? And we had this instance of a class. And so we'd look at our component and we knew that as long as that thing was mounted, it kind of existed over time and between renders. That's why we'd have to worry about state getting changed underneath us and trying to read it after we set state. It might be wrong because this thing exists through time. But these functions, they don't. It gets called, that world is over. It gets called again, that world is over. So somehow we need to assign this value to some place that in this next render, this second world, we can say, hey, actually, I know what you wanted. You wanted that state from before, that number that we're going to assign. I'm going to give that to you from somewhere else. So we need to go and put that somewhere. I'm going to call it states. And I'm going to keep an array of states in there. So this could work. I could say something like, I could say states. Well, let's push it in there. So we're going to push our tuple in. So the first use state comes around, and it's going to push this tuple in. So our states is going to look something like this, right? We're going to have 5, and then the set value function. And then the error use state is going to get called, and so we're going to come around, we're going to push in again. And so we're going to have another array in here that's got null for the error, the default error state there. And then it's going to have its own set value function also. So that's what our array is going to look like. As we're calling use state, we're pushing these things, these tuples, into a persistent, I guess, cache. It's like a persistent cache. So now we can assign to that, and then we can also pull from it between renders. So the trick, though, is I need to know the ID. I need to know, like, so for the first, if I click this button and I set minutes, what I want to do is I want to grab that array, this one, at 0. Then I want to take its first item and then assign it the new value. Good. If I was changing the error, I'd want to do 1, right? I want to grab this array and change its value inside of there. And then when I re-render, I can go and find it. So I've got to figure out what is the ID of this call to use state so that I know which one of these items to go and update. What's the difference between these 2 calls to use state? Could we like try to be super magic and look at the name minutes? Like Angular 1 would call toString on your function and look at the name of the parameters that came in. And so then you couldn't minify your code. And you'd scratch your head and think, have they ever shipped anything to the web? That was, yeah. Yeah, there are 4 cities. Is this going online afterward? It is? That was literally the reason I didn't use Angular It was like, nope, they haven't done this before. I mean, I found other reasons too, but that was the main one. Let's edit that part out. Okay, so how do we figure out, this is live, you can't edit it. Like 3 jokes, we're like, no, nope, move on. Okay, so we got to figure out this ID. So what is the difference between these 2 lines? Well, one was called first, one is on line 22 and one is on line 23. That is good enough for me. Let call count equal -1. My ID is ++ call count. So every time we call useState, we're just going to increment a count so that we know which useState call are we looking at. And this is fine because this is us, right? We're implementing useState. The app has no clue about these call counts, doesn't have to worry about it. And so I increment that thing. This is going to be 0 for the minute state, and it's going to be 1 for the error state. Cool, so now I can update that value, and then we need to re-render. Let's call it render phony hooks. These aren't real hooks, they're just kind of phony ones. I'm going to move all this code down to the bottom as well, because that's where we actually render. So this is a critical part of hooks. You have to own rendering. Sometimes people say, well, I just don't understand why React didn't make it a third-party library and then everyone else could use it. It is intimately involved with rendering, because when you update a hook, you have to know all the internals of the render tree to know which part to kick off and re-render. And so for us, we just own the whole tree right at the top. Let's see how far we got. Let's see what it looks like. I'm going to console log my minutes, or sorry, my states. That's what I call them. Yeah, states. There it is, our array of 2 items in there. That's what we expected, right? The 5 in a function to change it and null in a function to change it. So when I click this button, I'm going to call set minutes. Set minutes is going to come into here and it's going to find our old value, our 5. It's going to set it to a 6. Then we're going to re-render. And we're going to cross our fingers and hope that everything works. Oh crap, my array has 4 items in it now. But this worked. We updated the 6, but then we went ahead and created some more tuples. Quadruple tuples. I haven't said that before. I like that. Quadruple. Quadruple. All right, I'm done. So the problem is our call count is still going up, right? So we need to stop doing that. So set our call count back to -1. So every time we render, we say, okay, reset the call count. It's a new render of the whole thing. And so now as we come back and start calling useState again, we're starting at -1. And so then we can say, hey, I've seen this state before. So I will just give it to you instead of setting up a new one. This is where your class instance went. Instead of keeping track of instances of these classes, React now just has to track your states. And then your components get to just be boring functions that React can just call and say, hey, what you got in there? That's all React cares about. What do you got in there? And then how many times did you call useState? Now we're able to return whichever thing we just updated, right? We went and found it, we changed it to a 6, and then we re-render. And so when we call useState for the first time, we want to find this thing and say, this is what you wanted, right up here. Right there. We're doing a new render. Our call count's -1. We call useState, call count is 0. We go and we look up that state that we were tracking, and then we return it. And it's got that new value sitting inside of it. So I'm going to save this. Hey. So, not too magic. It's just just some global state that we don't have to keep track of. That's React's whole job. It keeps track of the DOM too, right? Like you might object to that and say, oh, well, global state's bad and even React shouldn't have it. That's its whole job. We've got this DOM. That's a global thing. And that's why we brought it in, because we're bad at keeping track of global state. And so we say, React, please keep track of the DOM for me. And now we get to say, also, I wasn't so great at keeping track of my class instances either. So why don't you go ahead and track this state for me? And then React, because it knows the deep internals of how it renders and which components show up, which ones come out. It can keep track of all of the call counts for all of these states and do it wonderfully. So this is why you can't do a conditional hook, like if minutes is less than 3. You can't do this because then our call count is off and React won't be able to find all the hooks that you rendered before. And it's nice because we can lint against this stuff really easily. You can add, there's some new lint rules from the React team that can tell you like, oh, hey, watch out, that's not gonna work with our abstraction. And you get used to it pretty quick. So there you go. Phony hooks. Thank you very much.
All right, did anyone have any questions? We're doing questions at
All right,
Denver?
we'll hand it back to you, Paz. No questions here on this end, and Ryan is already setting up, so or putting everything away. He's done for the night. Back to you guys.
Woo! Okay. Can you guys hear me okay? Can everyone hear me?
Chicago can hear you.
All right, very cool. Well, we want to say thank you to everybody who came out tonight. We know it was a little bit longer, but all the speakers and all the organizers for doing this and the sponsors, especially for Northwestern Mutual for just kind of staying with me through this. So this is the third one. We're excited to have a fourth, hopefully later this year. So again, go like React Power, is that a thing? I don't know, I think it should be. But hashtag React United for any questions, but thank you. Oh, sorry, ReactJS United. It's even late for me here. But I just want to say thank you to everyone. And cheers. Have a good night. Thank you. Woo!